Good morning. Good morning. This wonderful sunny morning, we're going to open this symposium on open access, which sounds, of course, like a very dull subject, but I assure you, today will be exciting as hell. Open access is the new kid on the block. Everyone's talking about it, but no one actually knows this kid. And today we're going to know who this new kid on the block, open access, and open data actually is or are. It's a twin, you might say. My name is Martijn van Kalmthout. I'll be your host today. This being said, I'd like to invite Daniël Lakens to the stage, please. Daniël is an inhabitant of this university, actually. He's with the Human Technology Interaction Group, and he's very vocal on the subject of today's symposium, open access and open data. So, Daniël, please take the stage.
Okay, thanks. Okay, good morning. So it's great to see so many of you here today, and I'm guessing that my main role here will be to explain how, as a researcher, because I'm not really a funding agency or a publisher, but I'm just a researcher who tries to do research in the best possible way. And for me, that means, of course, that I try to share my data with as many people as possible. And what I hope to do is to explain how to do this as practically as possible, right? So it's very easy, and I'll try to give you a lot of sort of examples of what you can do today. I had to stop myself from recommending you from doing some of these things instead of this workshop, but some of these things are so important that, you know, well, not you shouldn't leave the workshop to do them, but then at least this evening, or at least, the very least, tomorrow morning. So I'll talk a little bit about how important it is to share research. And one of the most basic starting points for me personally is the realization that I'm paid by the general public to try to figure out what's likely to be true. And I hope that we all agree. I often ask this question. People rarely disagree. I think this is a very basic thing, right? As a scientist, I'm paid by the general public to try to figure out what's true. So to do this, there are some things that are important. Of course, my research needs to be of very good quality. I need to draw valid conclusions and unbiased conclusions from my data. I often talk about those things because those are maybe equally problematic as sharing data. But the main point is that you need to share your findings. And I'll talk a little bit about how we currently share our findings. Now, one of the things that are very clear is that when we share our findings, what we share is mainly the stuff that worked. So we mainly share positive results. And this is a graph of a lot of different fields and how much of the published research that they share works. So it confirms some hypothesis. Now, I'm here at the bottom. Being at the bottom is rarely very good. So our field, psychology, shares about 94% successful research results and very few, or let's say almost no, research results that didn't work. Now, that led some people to joke that if we have such a good percentage of success, maybe then we don't need to do the research anyway, because everything we do works out. So we might just as well say, well, we have a great idea, and this is it. Let's skip the data collection part, because we know it's going to work anyway. Now, if you only share everything that works, that's a big problem, because basically this is referred to as publication bias. And this is such a severe problem that if you have a field that's riddled with publication bias, it means that you're not a quantitative science. We like, even psychologists, experimental psychology in any case, likes to say that it's a quantitative science, that we can make statements about what's likely to be true. But if we don't share the field's output that didn't work, then basically we have no idea to quantify the likelihood that things are true. So I can immediately go back to the starting point that that's actually my goal, to figure out what's likely to be true. And then I already see that there's a problem here. So I need to do something about it. So there's a lot of criticism that if you look at the published literature, maybe more than half of what we publish is not true. There are some very striking demonstrations, for example, in cancer research. Now, I know that as a man I have, I think, a 1 in 2 or 1 in 3 chance of getting cancer somewhere in my life. So I would like it if the research that's been done on this topic, they have another 20, 30, hopefully 40, 50 years, I don't know. But by that time, it would be great if they have learned what's likely to be true so they can cure my disease as far as possible. Now, if you try to replicate innovative cancer research, then you see that most of these studies indeed don't replicate. So that's a big problem. This is a nice paper that explains why these things happen. One of the major things is publication bias, that we only share stuff that works. If it's only 1 in 20 studies that work, then we basically are not showing anything that's true. So the challenge here is obviously that we're trying to do science, which is a long-term collaborative effort, in a reward structure that rewards short-term egoism. If I have this one single publication that worked, then it's not in my benefit to also share these 6 studies that I did before that didn't work, because that makes it look like that one study that worked was just a fluke. Even if it is a fluke, I might be very tempted to publish this one paper, because that's pretty good for my resume, right? So that's a real problem. Now, what can we do about this? Well, it's important to realize what the scientific norms are supposed to be. And some of these norms, this is pretty old work from the 40s, so these are norms that scientists in generally think are important for science. And you can see some of the examples: communality, sharing your scientific methods and findings. Another one is organized skepticism, which requires that your scientific findings are made available for scrutiny by other people so they can check them. So I think that this is relatively, uncontroversial. I think that as scientists, we mainly share these norms. There are also counter norms, so to say, to these good scientific norms, which are, for example, that you might be a little bit secret about what you are doing, because maybe you think that it would be bad for you personally if other people figure out what you're trying to do and show it before you show it, right? So you might want to be the first person to demonstrate something. Now, for science, that's completely irrelevant. We don't care about who publishes what first, but of course, individuals, especially in their short-term egoistic nature, care a lot about this. So these two things are sort of in opposition, and research shows that if you ask scientists how much they care about these norms, things are pretty good. So people strongly, this is not a percentage, but this is how strongly they adhere to these norms, people strongly subscribe to all these norms that I just listed, to the norms, not the counter norms. Then if they have to admit how much of these norms they actually do, their own behavior, how much they follow these norms, you already see that there's a reduction there. People are not able to follow what they believe is the right thing to do. But it becomes even worse if you ask them about others' behaviors. They say, well, I mean, I'm pretty good. Psychologists show that people always overestimate how well they do, right? You all think that you're smarter than the average of the intelligence of the people in this room, which is logically impossible, but still, that's how people work. We're slightly biased. That makes life pleasurable. In science, it's maybe a little negative to overestimate how well you're doing, but at least we think that other people are not following these norms, right? So we're quite negative about these people. Now, it's and the other way around for the counter norms, by the way. So we think that we don't think these counter norms are very good in general, and we think that other people follow these counter norms much more than we do as well. So you see that this is something that's called normative dissonance, right? There's a difference between what we think we should do and what we do. Now, personally, I find that a very annoying situation to be in. We know that people try to resolve cognitive dissonance, for example, if you have conflicting beliefs. And in this case, we have conflicting norms. So let's see how we can change this. I think, personally, I sleep a lot better since I try to bring my norms in line with my behavior in line with norms. You can also do it the other way around, by the way, bringing your norms in line with your behavior. Okay, so what do we need to do? Well, the first thing is, of course, that you have to, I'm going to talk about sharing your research results in an open way. So the first thing that you need to do is to be organized. Now, I'm not talking about sharing yet. I'm talking about that you, in principle, could share your research because the data storage and everything is organized in a good way. Now, let's say, I don't know how many people are researchers in the room. It's useful to know. So they collect data, all right? So if I would ask you, for example, for the data and materials, or everything I need to reproduce your last, let's say the first study in your last paper, then how long would it take you to share this with me? Seconds? Yeah? Who would be there in 2 minutes or less? All right, so some, but not all. So I think the main difference between the people that can share everything within 2 minutes, which I think is a reasonable time frame, given that we religiously check our email every minute or so, then you have 60 seconds to find the file and reply. I think that's a reasonable time scale. I think the difference between the people who can do this and the people who can't do this is that they have a very organized way of storing their data and their materials, right? So that's where it starts. That's a very important thing. I never used to do this. I was always looking through all these files and folders. They were always named in ridiculous ways, and I couldn't find all my stuff. But if you change this, then yes, indeed, you should be able to send this to other people if they ask for it within 2 minutes or so. That would be a sort of sign of a good organized system. Now, how can you achieve this? So our faculty, or actually our department, Human Technology Interaction Group here at the university, realized that we actually did not have this organized in a systematic way. We left this to individual researchers. And we know that if you leave things to individual researchers, they have very strong motivations to explain why they shouldn't do things that take up time and effort, right? Again, this is related to their short-term egoism. It's not very beneficial or difficult to see how buying an expensive light bulb versus a cheap light bulb, right? If we have this choice, then we see that people are more likely to buy the cheap light bulb because you think immediately that makes sense. It's very cheap. It's very difficult for us to see the long-term benefits of a more energy-efficient light bulb. This works sort of the same way. So we created a system and a procedure, and the procedure is maybe more important than the system. You have to have a system to store data, but it's also important to have a good procedure for people to share their data. Now, we call it Archi, because apparently this was some sort of cartoon in the 60s or so. I don't know. The people who programmed Archi posted this picture there. I don't know if you recognize it, but okay. So this is an archival system. It's an internal solution, so it's what we use in our department. Everybody can use their own system if you want to, I guess. Data is stored for at least 7 years there, because in psychology there are some indications that, some rules that 7 years should be a good one. You can store it longer if you need to. What researchers do in the system is they can upload all their data when it is collected. Later you can append information. Maybe you've done some analysis or you want to share other manuscripts or things you've written about it. So you can upload all this later, but you can never delete it, right? The goal is to get people to collect all their data and at least, at the very minimum, upload everything that's raw data related to running the experiment, all those kind of files, right? So you upload them, and there's some metadata, not very much, but things like the sample size and the age of the youngest participant, for the rule that you have to store data for 7 years after the youngest participant has turned 18. Okay. Any case. Now this is the electronic part, that you have a place to store it, but how do you get people to use it? Well, we have a system that works like this. First of all, you submit a proposal to your ethical board. We do research on human subjects, and psychologists always want to give electrical shocks to students. So we have to sort of balance this, that whenever they give these electrical shocks, it's sort of useful. No, actually, we don't give electrical shocks, but okay. There's always an ethical component, so they have to take a look. The ethical proposal also contains information about, for example, the power of the study, the statistical power. So how well is your study designed? There's a check before you collect this data. That's also an ethical requirement, I think, to make sure that if you do a study, that taxpayers' money is spent in the best possible way. So the ethical board also takes those things into consideration. You get an okay. Then you can perform the study, and then afterwards you upload the data and the materials. And this is all sort of kept track of in a spreadsheet where you can see which phase you are in, what you need to do. Now, it would be great if at the moment that everybody has to upload their data, everybody's like, oh, I'm so intrinsically motivated, this is so good for science, and actually I don't have any meetings today, I don't have any teaching, I don't have any other obligations, so let's sit down and organize this. Well, regrettably, that's not how it works. So people need some sort of external motivation to do this. Even I'm really standing here convincing you that this is very important. Even I need external motivation, a deadline, to get this done. The first step that we had in this system was that there were no deadlines. There was just a friendly reminder email for every study. So at a certain moment, you get 12 of these reminder emails, that you would please upload your data. Now, that didn't work because it's too free. Right? People have always more pressing things to do. The second step was that data upload required you to be able to hand in, data upload was required to be able make a declaration for the study you've performed. So if you have paid participants, then if you wanted to get the money back, you had to upload your data. That also didn't work. It was a great way to get people to save for retirement, because at a certain moment some colleagues had like 2,000 or 3,000 euros of possible money they could declare. But even that was not good enough to make them hand in the data. So the last step that did work was that we prevented people from uploading a new experiment proposal before they could. They had to upload the data of old studies within a certain time frame, let's say 6 months. And if they passed this deadline, they were not allowed to do new research. Apparently that works really well. So researchers want to do research. They don't care about the money, at least at our department, but they do care about being able to do new research. So if you prevent them from doing new research, they all of a sudden say, oh wait, let me do it, and it's done, right? The system works, people are not revolting or complaining, so it's not very difficult. So this is the system that we have internally. Now, if you want to share your research, then the first thing to realize is that it doesn't really stop there. It's great to be organized. That's the very, very basic thing to do. Then it's good to have, as a department, some sort of rule of how you organize collectively the data storage and make sure that everybody follows this. But then becomes the more interesting part that we're going to talk about today, which is how do you get people to openly share this data? Why should you want to do this? Now, I think that, first of all, it's important to realize that if you're paid by taxpayers, then every research output that you produce is not yours in any meaningful way. So your data is not yours, but even the materials you created are not yours. Taxpayers have paid you to create this data. And when you're done with them, you should share them as widely as possible for other people to use them. Because if everybody does this, of course, science becomes widely more efficient. Now, everybody is creating their own data analysis scripts, their own stimuli, their own whatever, right? But if we all share this collectively, it's much more efficient. So, to facilitate this, you should try to share everything related to your scientific output. Now, very easy question. If I want to read all your work, for the people who write papers, is it possible for me to download all your papers without having university access? Can you raise your hand if you're pretty sure that everything you do is downloadable? Okay, so that's not everything, right? That's not everyone. Now, I think it's very important to do this. I always like to note when things like, norms, like let's say general norms, what's good for science meets with what's good for you, and this is one of those situations. If you share all your papers, the preprints of your papers, then people are more likely to cite them. So this is really your own egoistic short-term reward is really lining up with what's good for science in general. If you share your research, people are more likely to cite it if they can access it. You can upload preprints to ResearchGate or academia.edu or your own personal website. Google will find them. I mean, there are probably more ways to do this that some people here in the audience are more aware of. This is just what I do. What's most important is that if people Google your research or your name, that next to in Google Scholar, because I know librarians are still teaching students that they should use all these internal systems, but I mean, I don't even do this. I always only use Google Scholar. So what's important is that if you are on Google Scholar, then next to your article, there should be this link, a PDF of your work. If it's missing, you're doing something wrong. This is the moment where I should say that I was tempted to say, go home, fix this, and then go back. But this is a very basic thing to do. It's in your own self-interest. Now, you might wonder, but how do I know whether I can share my preprint, right? The nice fancy layout version, typically you're not allowed to share, but the one that you submitted, the final draft that you submitted that was accepted, you are often allowed to share. So this is a website that keeps track of whether you're allowed to share your preprints. You can search for a journal title. This is one in social psychology where I work in. And then you get this information that you can share. There's these green ones that say that you can share your preprint, but you cannot share the final version. Not surprising, but you can share this preprint. That's important, right? So if you have not done that, of course, that's starting point one. I'm starting with the very easy things. This is in your own self-interest to make sure that you've done this. All right, now you've shared your research. That's already great, but of course you also want to share your data and your materials, because this is all going back to the very first slide. We are paid by the general public to figure out what's likely to be true, and they've paid for this material and these results. So they should be able to work on it. Now, how can you do this? There's one solution that I use and that I'm talking about today because I'm a big fan of it, but also officially an ambassador of this project. This is organized by the Center of Open Science in the US, and they have made something that's called the Open Science Framework, which is so obvious for me that I didn't even put the full words there, but it's called the Open Science Framework. There's a link later on. Now, in this Open Science Framework, you can store everything that you're doing while you're working on these projects, and you can decide to make this public or not. You can decide to make it public after the research is accepted or not. The first step is to create an account. You can do that here. It's free. And storage is also free. They have millions of dollars. And they have a fund that will guarantee that all the data that's stored there is stored there for I don't know how long, even if they end up not being around anymore for the next foreseeable future. That's not a problem because they have enough financial resources. But they guarantee the fact that this data will remain available even if for some weird reason, nuclear war, for example, the OSF would be gone. So this is the website that hopefully you'll go to, and then you can try to share your data, for example. Now this is an example of a project page on the Open Science Framework where I shared research that I did with a colleague and from a paper that's published. And when it was done, we are keeping track of all our data here, trying to keep it organized in different folders. And then when we were done and the paper was accepted, you just press a button here, which says make it public, right? You cannot do that if you don't want to do that. The fact is just that, first of all your data is stored there for free, so that's great if you're afraid of computer crashes. But also it makes it very easy, very low threshold to at the end just say, okay, let's just share everything we have because it's there anyway. There are some advantages of doing this. You can put any source of information there and get persistent citable identifiers, so people can continue to cite your work. For example, here in the bottom, right? Doesn't matter what you share there, people can cite it. In addition, what I really like is that there's something that's called Dropbox integration. Now, I know that we're talking about moving to Surf Drive. I don't know if you know this discussion. Maybe we don't want to share our research data at foreign servers. That's all fine. I think Surf Drive could be easily integrated with the OSF when it's rolled out completely. For the moment, I often use Dropbox to share data with collaborators. And Dropbox integrates very nicely with the Open Science Framework, which is very cool because automatically everything is uploaded to the OSF, but also it keeps track of version control. So even if I make some changes in my Dropbox and I overwrite a file I was working on and I lose something, then the OSF will have stored older versions of this. So I can always go back to what I had. So you not only always have your data available, but you also have all past versions of your data available in case you need it. Again, this is all free. So that's also useful. Another great function of the Open Science Framework. So I started out talking about publication bias and this being a problem. Now, one of the solutions for this, so to share everything, is that you can pre-register an experiment. And then nowadays it's even possible to get this pre-registration, so this proposal of the research that you'll do, you can get this accepted for publication before you have collected the data. Just based on the proposal, you can get something that's called an in-principle acceptance. The reviewers and the editors will say, okay, we made some changes and suggestions, but if you follow this proposal, then whatever the outcome of the data, we will accept it and we'll publish it. That's a great way to prevent publication bias. I think that the OSF makes this very easy to do these registrations. So what you can do is you can have your own project page, then you hit this big button, register, you fill in some data, and then some information about the registration, and then you get a frozen copy of your project page, which will never change, and people can always go back to this proposal that you uploaded, where you say, okay, this is what I planned to do beforehand. I can't change it anymore. It was frozen 4 months ago. And then you can put this link, you get a new link. You can put the link to the registered proposal in your submission, maybe even just in a normal submission for a paper. If you don't want to do this pre-registered proposal, that's also fine. You can share it and you can say, well, all my analyses were planned beforehand, right? There's nothing fishy about this. I'm just reporting what I thought I wanted to do beforehand. Okay, so you can fill it in, and we've recently used this to try to battle publication bias in psychology by, for example, having this special issue, which was It contained about 13 or 14 studies that contained pre-registered replication proposals. In this case, it was specifically for replication research, which is also rarely done. It's not possible to get funds for this. If you want to go to NWO to do a replication study, they're never going to say, oh, you want to check whether things are robust and reliable before we build on it? Great, here's some money. So you have to get another way to do it, but at least for a special issue like this, it makes it possible for people to perform these replications and get them published. So there's at least some reward there. And nowadays there are more and more, I mean really this list, I could update this every week, but there are more and more journals that are starting to accept these pre-registrations. So that's a great way to use the Open Science Framework to get a registered research proposal and to share it with these journal articles that will accept your results no matter what the outcome. Just if you have a great theoretical idea, for example, right? Okay. Now I'm talking a lot. There's room for questions, right? If you want to ask a question about it, feel free to do it. There will be room at the end, but okay. So the basic change here is that normally we have a situation like this, right? That you design an experiment, you collect and analyze everything, and then you report your data. And then here there's peer review, where some of these experts in the field tell you that you were an idiot for doing the experiment the way that you did it, and you have to completely redo it. Now, in a pre-registered research proposal, the peer review is shifted after the design, after the proposal. Then you get these experts that tell you all the mistakes you would have made and all the time you would have wasted. And then you can collect and analyze and report the results. Often there will be a second round of reviews to see whether you did everything correctly, and then it's published. Right, so this is an example of such a pre-registration. You can even share these pre-registrations. So you see here that this is work, ongoing work that I'm doing, registration for a research project that's going on. And I make this public, right? So I'm pretty convinced that being as open as possible is a good thing. Now, why am I making this open before I've done the research? Because I think it makes sense that if other people also want to do something like this, they can get into touch before we do this independently from each other, because that's a little bit of a wasteful effort. If multiple people are doing something and they're not collaborating, you can say, well, it's always good to have more studies about something, but what nowadays typically happens is that one person publishes it, and then other people say, well, we already know this, right? So it's a really wasteful thing. So if you pre-register your experiment and make it open, I'm really saying this is a little hardcore maybe for beginners. This is not a beginner thing to do, but you know, it won't hurt. But that's a good approach. You see that some meta-analysis nowadays do this. They say, okay, we're going to do this meta-analysis about this field, and they make this widely known to prevent 7 other people from doing a meta-analysis on the same topic. That's also a bit of a wasteful thing to do. All right, so you can share code, simulations, whatever you want, right? That's also a good approach. For example, there are other sites, not only the OSF, the Open Science Framework, but GitHub, for example. You can share all your code there if you want to. You can even share your presentations. So if you want to download this presentation, you can just go to my Open Science Framework site. You can download it there if you want to. You can share everything you want, anything you do. Now, there are now some journals that recognize that this is a nice thing to do. And in psychology, we're really about people, right? That's sort of what we study. So what we do, and what some people came up with, the Open Science Framework also coordinates this, is the idea to give people who, let's say, live up to these norms, to give them a badge. This is more or less like the sticker that you got in kindergarten from your teacher if you do a good thing. You get badges, for example, for open data or open materials, or if you pre-registered your results. And maybe you think that's a little silly to do. Why would you do that? But the fact is that after these badges were implemented, all of a sudden it can become visible for you to adhere to these norms. And people are very sensitive to social norms. And it also gives them an opportunity to finally do this. There was a huge awareness. Nowadays you see that in some journals, like Psychological Science, which is a pretty good journal in psychology in general, you see that there are these badges next to this article. Pre-registration is still a little rare because this is very new, so it takes a while for these pre-registered studies to end up here, but they will appear. And I think that you'll agree with me that, let's say you would be here with your nice article you're very proud of, and you don't have these badges. Well then, you know, it looks a little silly. Why don't you have these badges? I mean, it's perfectly fine not to do it, but I think this is a nice way to show that you adhere to these norms. All right, now what would be great about this? So we're trying to convince as many people to share their data, and I think that's all very doable nowadays, right? But of course, there are also some more long-term goals, and one of these things could be that it's great to have access to all this data, for example, for reanalysis or meta-analysis. But what would be even cooler is if you have, sorry, the slides go on sometimes. If you share all this data in some repository, all the studies that people perform, and you have a nice set of metadata about these studies. Because then you would be able to go to a specific research topic, I don't know, whatever you find interesting. Maybe I was reading that the TU Delft also has a symposium, but it's about, what's it called, homeopathy, right? Homeopathy, this medicine thing. And they were saying, well, there are meta-analyses that show that it really works. Then I thought, you know, it would be great if they also have this, all the data is shared, and then you can go to this website. This is an example. This is one individual effort to create an example of how it could be. So I think this is great. It's called Curate Science. And this person has made sort of an example. Etienne Lebel is his name, by the way. He made an example of how this could look like in the future, right? So if you would go to this site, it's not fully functioning yet, but almost everything is ready to go live. If you would go to a site like this, you could search for a lot of studies. There are some example studies here. And then you could see whether there are replications, because everything, all the metadata is stored, reproducibility statistics, but also you can have access to the materials and data or knowledge about it. It could look something like this, where you see that there was one initial study, which was a little bit relatively uncertain whether the effect was there, but at least it was statistically significant. And then you see that there are some bigger studies after that, and altogether they all show that there is indeed some sort of effect. You can get some statistics here and you say, well, according to the knowledge we have today, really at this moment, live, it seems that this is valid or not. So that would be great to have for a lot of fields, of course. Also in designing your study, you could go there and see, well, which manipulation do I want to use? Oh, this has the strongest effect, apparently. Well, let's use this. So I think that's really promising, let's say, a bright future. If we can get a lot of people to share their data, we can have access to great, real, great quantifiable knowledge. So this is moving from qualitative science to quantitative science, because we have access to everything, only here, right? If there's no publication bias, if we really have all the data, then our science would be much, much stronger. Now, if everybody would share all their data, I just wanted you to take a moment to think about how easy it would be to get materials, to get data, to do meta-analysis. All this work would become 10, 20 times easier, right? We would become so much more efficient as a science. And I think that alone is a very good reason to share all your materials. So some final comments. I don't know how I'm doing time-wise, but good, apparently. So I want to let you think for a moment about how we can move towards these things. So if some of the things I've been talking about were convincing, right? If you think, well, some of these things are indeed sound like a good idea. I hope that I've convinced you of at least some of the things here. You know, you can implement these tomorrow. So if you think that's good, then I want you to realize that in the end, I'm talking a lot about this difference between long-term collaboration and short-term egoism, right? But in the end, you are the reward structure. As scientists, or as editors, as reviewers, you are the people who determine what gets rewarded. So of course you can think about rewarding papers that adhere to good research practices. You have a very easy tool for that. You can determine what you cite. So you can choose to cite work that adheres to open science principles. There's nothing wrong with that. If you have multiple citations you could use to say that a point is shown in literature, for example, you can choose papers that adhere to these norms. As a reviewer, you can also reward openness. If people share all their materials and data, you can say, well, you report this specific analysis, I'm not sure. You know, you can debate whether this is the perfect way, but you know what, you've shared all your data, so I'm not going to make too big of a point of it. If other people want to do another analysis, they can just add, access the data and take a look at it. I have to say that since I've been doing open science like this, I've always shared all my data with the reviewers, because everything is ready the moment I submit it. So I can make this public and I can share it with the reviewers, and all my papers have gotten accepted. Now, this is not anything statistically valid, of course. It's true, but I think that in general, I do get a lot of positive notes from reviewers and editors, that they really appreciate this. So I think, it works in your benefit. As an editor, so I'm an editor at a journal, I can also try to reward openness. What I recently did for the first time and I'm surprised how well it worked, was at the moment that the paper was ready to be accepted, I always read it through final time and I make some final notes. I say, okay, change this and add this, and then, just dotting the I. And at this moment, I also added to this email, although it is not a precondition for acceptance, I think sharing data and materials exemplifies the true scientific spirit and facilitates cumulative science. So I just asked them to share everything, and within 3 days, they dotted the I's in the manuscript and they added a link to all the raw data and the materials. I think that's great. It was so easy. I never thought that I could just ask this and then more people would share data, but that's sometimes how easy it is. So you can also consider doing that. There are some people that go a step beyond this and they say, well, if I only have so much time, which is true, time is a limited resource as a scientist, they have said, well, I'm going to spend the time that I review only on articles that adhere to open science, right? I think, personally, I signed this Agenda for Open Research. I think that there's really, you can justify the fact that you are not sharing anything. That's fine. If you have a good justification for it, I'll happily accept, the task to review your article, even if you're not sharing data. But if there's no justifiable reason for not sharing the data and the materials, then I'm really not sure why I should spend my scarce time reviewing your paper if I could also review the paper of someone else who is adhering to these open science norms. So there are now a group of people that say we're going to start in 2016, January 2016. We will only accept review invitations from people who adhere to these scientific norms. I think that's at least an interesting thing to do. I don't doubt that I have more than enough to review, even if I limit myself to people that adhere to open science norms. But I think that's also something you can do as an individual if you want to. Note that many journals, and probably the person who talks about +1 later on will already talk about this, many journals already require exactly these kind of data sharing. Justify it if you cannot share it, otherwise share your data. All right. Now also if you happen to manage research, so I don't know if they're managers of research, but I think it's important to realize that you should reward research that lives up to this ideal of the axiom in the starting point. Research that tells us something about the likelihood that things are true. So that means that you should reward openness, collaboration between individuals, good research practices before productivity. Productivity is also nice. You can choose to reward that if you want to, but let's get the basics straight here. The basics are that people should be rewarded for openness, collaboration, and good research practices, and only then for productivity, not the other way around. I think it's important that people will often say, well, of course I think that's possible. It speaks for itself. Well, take every opportunity you have to clearly communicate this reward structure if you officially really believe it. Okay, that's all I have. Thanks.
Thank you, Daniel, for this excellent presentation, which more or less sounded like a sermon on open data in my ears. But perhaps we have some questions or remarks from the audience. Who would like to volunteer? No hands? They're all very secretive about their questions,
I think so.
I have a question myself. Actually, you mentioned valid reasons for not sharing data.
Sure.
What might that be?
So sometimes data, if you share data, then there are privacy concerns. So if I have a study that I've performed at my university and I report this as a psychologist, and I have, let's say, 100 individuals, and I say that this study was performed in 2010, and I ask these people to specify their age and their gender, and I ask them to write about their sexual fantasies, then it might be possible to have a pretty good guess who my participants were. If you can say, well, it has to be a student in 2010 and a man and then about 45. Well, there's only actually one of those. So that's a good reason why you should not share maybe all your data. Maybe you could share one column in your data set, just the data on the sexual fantasies. But even that might be very difficult, because if I have strong sexual fantasies about having sex with Martijn van Kanthout, then maybe I don't want to share that, right?
Okay. I wouldn't either. Okay. But that's one very specific
Yes.
example, of course. In general, would you say there's many reasons to not share, or valid reasons to not share your data?
I think if you look at journals that now have these requirements to share data, maybe the person who's in charge of, going to talk about +1 is probably the better person who have data on this. But I'm guessing that the majority, definitely the majority of the articles share their data. But how many studies don't, I don't know. So I don't know what the percentage is, but the majority by far is able to share data, and probably all data.
Right. Well, I was surprised at one point that you didn't ask the audience who was actually sharing their data already.
Okay,
so
we can do it.
Shall we try it?
Yes.
Who is? Who's doing this? Just a few. Okay, that's 3 hands in 150. That's not too many. Anyone of these hands would like to comment on how this works in practice? For instance, you, sir? Could you explain, is your practice along the lines Daniel has shown us, or what's actually what you're doing?
Well, I don't use any of the official tools because I was made aware of them only too late. So we have a file server at our own group, and I've put my data there and a link to that to my personal webpage, and that's also in my paper. And yeah, it's not very big yet, but once in a while I get an email of someone asking a question about it or something.
Yeah.
But yeah, so that's about it. But
I think that's already a great starting point, right? You can always do that. Although with things like the Open Science Framework or Dataverse or Figshare, there are other services like this. You can have more continuity. I hope you'll keep your job. I think definitely people who do these kind of things should keep their jobs in general. But you might not, or you might move, and the file server might move, or whatever. So continuity is important, I guess.
The other side of your story, of course, is people wanting to use the data.
Yeah.
I'm not sure there are any, but perhaps we can ask again. Sharing data as a user, who's interested in that? Hardly anyone. So I get to the point, but first of all, you seem to be interested in using other people's data. Yes. For your own research, I guess?
Yes, actually, I'm an industrial engineer, and sometimes it happens that I develop a new method that I want to see compared with other methodologies, and I want to compare working with exactly the same data as they did to compare my results. I think it's a better solution because I can never develop all their method again, but I can use the same data and compare my results. That would be a lot easier.
Right. Would you say people are willing to share their data? Is that a common practice or the exception? What would you say?
For me, it happened once that I wrote to the author and asked them if I could have their data, and it was possible, but I don't think generally it's possible and very welcome among all the scientists. But I myself am very happy if I can contribute with my data to help other scientists.
Okay, thank you.
You're welcome.
Other comments on this? Back to Daniel. Actually, this using other people's data in your own practice, how often does that happen?
Well, it depends maybe a bit on your field. So I can answer from my sort of
which is psychology, social psychology.
Yeah, but I think this goes for humanities and medicine, and basically all fields that are based on statistical inferences. And in those fields where you use statistics to draw conclusions, then basically any data point, a single study, is just a single data point in a future meta-analysis. It's nice if you have one study that tells you something, but definitely, given publication bias, it's not enough. So what you see is that after maybe 5-7 years, then people will start to do a meta-analysis on all the study that's performed, all the studies that are performed. And then having access to the data is great. People can try to report all statistics, but often we see that there are new statistical techniques. People did not report the correct data to use these newer statistical techniques. So having access to raw data is important for cumulative knowledge. So if you want to, after a couple of years, say, okay, let's put everything on a big pile and see whether homeopathy actually makes you healthier or not.
Okay, but in your own practice, would you say...
There's a...
Yeah? Okay. Kasmaassen, please. You have a mic. Number
Mike?
4.
Yes, okay.
Yeah.
Yeah, my name is Kasmaassen from NWO. I would like to know a little bit more about when you use your data, how easy is it to use the data? Because I think, you know...
Of other people, you mean?
Of other people, because the circumstances where they did their study could be very different from each study. And how easy is it to use those data? And what do you have to do to be able to use them?
Well, to use the data, in essence, you have to be able to analyze the data and reproduce their results. I mean, in part, just reproducing results after a couple of years might be good as new statistical techniques develop. I mean, statistics is not a stable field, right? There are always new things that you can do with data. But in meta-analysis, this is exactly what happens. So the question, how well can you use this data together? In medicine, it's just what people do, and in humanities as well. We try to combine data. There are, of course, questions, how comparable are studies? There are statistical techniques to indicate how much variability there is and try to explain it. So, but that's more a statistical question. The basic point that you need to have access to data, or that you can do better science if you have access to data, is not really an issue. And then people should be trained a little bit in how to make sure that the data they share is indeed reproducible. So that's a very important skill to have. Data management itself is a very important skill to have. I didn't even know that when I still used SPSS, for example, I didn't even know that SPSS has a way to save data, so that's a statistical program, that is a stable format that will never change, and that's guaranteed to be able to be opened in this statistical software in 20 years when we're at version 2017 instead of 21 that they have now, 22 or I don't know, right? So I didn't even know this. So this is an important skill to how, but I would say that if you want to know that, you should access or ask help from librarians who are extremely skilled at these kind of things. But these are practical matters, I think. Yeah.
Okay, thanks.
Okay, thank you. Yes, please. Can we have a mic up here? Perhaps if you want, you can state your name and perhaps your affiliation as well.
My name is Hillebrand Verkroost.
You can hear you, yeah.
My name is Hillebrand Verkroost. I work for the Energy Research Center in Petten. And I'm not a researcher, but an information specialist, which was called a librarian in the old days. I have a question about this open science framework. You are an ambassador of that, but I understood that there is also a data center in the Netherlands that is collecting data for researchers also to upload their data. Why not be an ambassador of that?
Well, I think you're talking about DANS, maybe, right? The DANS network, or?
Yes.
Yeah.
Yeah?
Well.
Oh, sorry. Yeah, the mic is gone.
Can we have the mic
guessing,
back again?
I mean, so there are multiple ways to share data. Let's be clear about that, right? So we're talking maybe, well, first of all, there's no central rules that tell me to do something. Right? So if the scientific community in the Netherlands tells me that I should always store my data on Dutch servers, for example, and give me the opportunity to do that, I would do that. I would probably then use 2 services, because what I like about this open science framework is the ease with which it integrates in your daily routine. So it's very easy to use. And I noticed that some of the other databases are typically very at the end, you're supposed to upload everything in one big go. When I'm also writing the article and submitting the article, then there's all of a sudden sort of a chunk of work that needs to be done. Not a problem. I've used some of these Dutch data storage systems in the past as well. But I like this better because it nicely integrates with all my work. And I also have a lot of projects that don't end up being published. So should I share everything at these DANS or these national data? Everything that's published, data you can share there. But here, I can share everything. Also, student projects where I did a replication study, and I think, well, we didn't find anything. It could be us. It could not be us. I don't know. I'm not going to continue this project and get it published as a one-study-filled replication, but I'm going to make it available to other people for these future meta-analysis. Then they could take it along. We did our best, right? I'm not an idiot when I do a study, so I guess it has some value, and then I can share it. So there are a lot of things that this open science framework does, which perfectly fits my needs. And that's the reason why I think it's the easiest to start using.
But you're not saying there's just one solution, is that right?
No, no, definitely not. And I don't want to say that people should use this. I mean, I think it works very well for me personally, but the main point is that there are multiple ways to do this. Figshare exists, Dutch data science. Again, basically, if you want to do this, you can contact your librarian. They will know a lot of these solutions and maybe see what's best for you. But if you don't know where to start, or you don't have a librarian that knows something about it, you can contact these people from the Open Science Framework, and they will help you. So.
Actually, also talking about the 3 TU
Yes.
data center in which your university is also involved.
Yes, so I also store my data in the 3TU data center. Yes. Yes. I think we need to work towards a one comprehensive solution, or maybe 2 at a minimum. But now I'm sort of divided between 3 or 4 options, and I don't want to upload my data everywhere because that's also a bit messy.
Actually, you should take care that your study being in 3 databases shouldn't be counted for 3 studies.
Yes.
The meta-analysis.
Yes, of course.
Yes.
So, I mean, we need to work towards a sort of integrative solution. Yes.
Okay. What people should do is take a look. That's what
Yes,
you're saying.
and
Okay.
choose one solution. I don't care which
No.
one. Anything goes.
Okay, we have a few questions left and about 5 minutes, so go ahead.
Actually, I just had a comment on the last comment. I'm a PhD student here, and if I go do a postdoc, I won't be in the 3TUs anymore, most likely. So using a 3TU specific database is actually not so helpful if I want my data to be associated with my name in my future career, rather than with the Eindhoven University specifically.
Because it wouldn't be general access
So if somebody
material.
wanted to follow my own work, yeah, it actually makes more sense for me to use an international repository than a 3TU specific one, or both.
Okay,
Yeah.
good point.
I think at this moment, indeed, there's no perfect solution yet, so all have different strengths. Yeah.
Okay, one more?
Well, we have someone of 3TU here, so maybe he can comment on the last comment.
Please do.
Would you please repeat your question? I didn't hear it well.
I can repeat it if you want to.
Yeah. Oh.
I have a mic, you know.
Yeah.
The point is, she told us she'll be. She's at the university right now, but afterwards in a postdoc, she won't be in the 3TU framework.
Yeah.
So the data being stored there wouldn't be associated to her affiliation at that moment. Wouldn't it be easier to store this data not in a particular database, but in a framework like Daniël Lakens has shown us?
Oh, but yeah, that isn't an important point.
Okay.
I think 3TU Data Center, of course, it's affiliated with the 3 technical universities of this country, of the Netherlands.
Yes.
But it doesn't mean that we only store data of those 3 technical universities. Other people, are welcome to store the data also in 3TU Data Center.
I see. So it's an open framework again.
Yeah, in that sense, you can call it also an open framework. Yes.
Okay.
I think this importantly points out that you should talk to your librarian if you want to store data, if you have one that knows something about it, because it's a new thing and we don't know everything about it, right?
Right.
It's something we need to learn about, how to do it well.
Well, although we should remember that a librarian is called an information specialist
Of course,
right now.
an information
Yes.
specialist.
Okay, final question or remark. No one? Yes? Again?
Just a comment on why not to share your data. According to me, it costs a lot of work. Recently, I read a blog post about a researcher. He said, okay, I have my paper, I want to make it, as he called it, open science. It cost him 36 hours of work to make his paper open science. And in his opinion, and he is right, were alternative costs. So in this time, he couldn't do another research. So 36 hours of work is a lot of time. It's also about documentation the software, of course, adding metadata, etc. And I think perhaps you thought a little bit too light about that about that aspect.
Yes.
Of course, you have to share, but before other people can use your data, they have to be usable, and that costs a lot of work.
Okay, good point.
Yeah, so what I think is important there is that I never take 36 hours to share my data, and probably the reason why is that there is some, let's say, golden standard of sharing your data, which I'm not reaching. So if I would reach this 100% perfect data sharing way, I would indeed document everything. So sometimes I'm crazy enough to upload my data, and there are some Dutch words in there that I did not translate. So I know that people, at least have to find a way to translate it if they want to. Or maybe not everything is perfectly commented on, or my script, my data analysis script is perfectly understandable for me, but would take a lot of work for someone else to completely understand. I mean, they can run it and get the same thing, but maybe they don't understand what I'm doing. And I don't care too much about that, because I think that, if there's a rare situation where data is so hugely popular or whatever, that people will need, access it a lot, and I get more emails about questions than it takes me time to fix it, then I'll probably update it, which is also good. So you can do that on the Open Science Framework. You should be able to update your own data if it's necessary, right? A new version, keep the old one, but also a new one. So I typically probably reach maybe 60% optimal open science. At least everything is available, but it's not according to this golden standard. And that it's probably an exponential curve. So making your work a lot more open and science a lot better is very easy in the beginning. And then getting this 100% mark is very difficult, but I don't try to do that in general.
Okay, good point. Thank you again, Daniël Lakens.
Okay.